How's it going, and welcome to my mini series on the Python library NumPy. So when it comes to different types of science or engineering or software development, when you have to do some sort of numerical computations, a lot of the packages that are used to do these things rely upon the NumPy library, and the reason being is because it allows you to vectorize and optimize a lot of the numerical computations needed to do different types of science or engineering research or projects. So it's a library that I use quite extensively in working on certain types of data science projects. And I would like to just kind of go through and get a good understanding of the basics and kind of do an overview of what exactly is NumPy, why you might want to use it, and then walk through the different steps of how to use it, how you can create different types of NumPy arrays, either initializing them from scratch or converting other Python objects into NumPy arrays and stuff like that. And then how to give some kind of use cases and examples on downstream tasks, how you can utilize the functionality built into NumPy and then also packages built on top of it in order to do data science and to speed up your computations and to optimize your algorithms within Python. So let's go ahead and get started and kind of take a look at the NumPy documentation, looking at basically a good welcome to NumPy. So like I had kind of lined out, it's a numerical Python. It's open source Python library used in science and engineering very heavily. The API, NumPy API is used extensively in pandas, SciPy, Matplotlib, scikit-learn, scikit-image, and then other data science and scientific Python packages, right? So these other packages are built on top of NumPy where they have their own functionality, and then under the hood they're using different types of NumPy operations. NumPy itself is, I believe, written on top of C, which allows us to interact and actually allows you to run things faster, and that's a lot of how they the under the hood workings of NumPy is has the different C bindings and is which actually allows it to be optimized and run so quickly. So NumPy library contains multi-dimensional array and matrix data structures. So that's kind of the general consensus of the library, is that you can either build these vectors or matrices or arrays, these data structures that they hold homogeneous n-dimensional array object, right? So homogeneous meaning that each object within the array is of the same data type, and it takes up the same amount of memory So NumPy can be used to perform a wide variety of mathematical operations on arrays. So adding that powerful data structure can guarantee efficient calculations with arrays, and then it supplies a enormous library of high-level mathematical functions. So so basically, maybe to kind of give a good example is if you're going to, like a good, maybe like kind of real simple example of, kind of the difference, right? So we're going to go ahead and import NumPy. So let's say we have like a Python list. So let's just say values equals just a normal list. And let's say we've got a couple different values. Well, if you would want to add, element wise, add these values together, obviously using the addition sign with a Python list actually just concatenates them. It doesn't actually do any element wise computations. So what you'd have to do is, and there might be a faster way to do this, but what you'd have to do is loop through the list. So for value in values, or actually go ahead and do this. So here we go. I'm going to go ahead and initialize the new values list. And then what you'd have to do is something similar to this, where you loop through the values and then you add each element to each other to do the element-wise addition of these lists. So what's kind of nice about NumPy is you're able to actually vectorize these operations. So if you would do NumPy values, would actually be the NumPy array version of values, and then you go ahead and take a look at the NumPy values now. So it's basically just converted that Python list into an array of values. And then what's really nice about that is now you can perform element-wise operations. And there you go. You just add them together, and then now it performs an element-wise addition, right? And you can do this for all different types of mathematical operations. So kind of a really easy, basic understanding of like really basic problem of how NumPy can be used, and how when you create these arrays, how it can really speed up, and you can kind of see how it can speed up these different types of mathematical operations. So kind of going back to this, basically all you have to do is, get your conda environment going, or your Python environment. You can either conda install NumPy or pip install NumPy. And then like I've showed you, in order to use NumPy, you go ahead and import it. And the kind of standard way is import NumPy as NP. And then like you see here, whenever you want to call a NumPy particular function, you just pass NP dot that particular function. So yeah, so that's basically kind of the basic rundown. And then here's kind of some more nomenclature on exactly what the difference is between a Python list and a NumPy array. So NumPy gives you an enormous range of fast and efficient ways of creating arrays and manipulating numerical data inside them. So yeah, again, Python lists can contain different data types within a single list. So you can have like characters or strings or integers or floats. So that's different. So all the elements in the NumPy array should be homogeneous. They should be the same data type, and they should be, and then basically what that does is it allows you to optimize the mathematical operations, kind of like we saw, and then it's faster. And so yeah, basically one of the main reasons into why you want to use these, especially when you're doing mathematical operations, is it's a lot faster and more compact than the Python list. So an array, it consumes less memory, kind of what I had talked about. More convenient. You have a lot of built-in functionality, mathematical operations at your disposal using NumPy versus just Python lists. And then, yes, right. So you can also further optimize things. So one of the powers of the NumPy's arrays is the ability to be able to index things, and then able to basically. So if you've ever done any sort of linear algebra and stuff like that, you can start to do different matrix algebra or matrix calculations using NumPy's arrays, which allows you to vectorize these calculations. You don't have to do for loops. You can do you can actually just, do different types of matrix algebra, which is much faster and helps you to basically optimize and improve the speed at which your code runs. So, and then here's just kind of a breakdown of what an array is. So like we've kind of talked about, essential data structure of NumPy. It's a grid of values, contains information about the raw data, and then how to locate an element and how to interpret an element. So it has the data type, and then it also has these indices, its own grid. So you can index these in multiple different ways, which we'll kind of get into in a further video. Basically, kind of just wanted to give you a little bit of a rundown on the main ideas of NumPy, why you might want to use it, especially when you're trying to do any sort of mathematical operations. So a lot of the code that I write and work with is actually code designed to do some sort of analysis, and with that, usually there's different types of mathematical formulas, implementation of different mathematical formulas. So a lot of the times, in order to efficiently analyze and run these formulas on lots and lots of data, it makes the most sense to implement these things through something like NumPy, and it helps optimize the code and speed things up. So if you want, you can go ahead, and I'll actually put a link in the description below to this documentation, so you can read through it if you would also like. And then in the next coming video, I'm going to walk through the different ways to create NumPy arrays and walk through the different methods that come with NumPy and ND arrays, and kind of talk about how to create them. And then we're going to move forward after that into different types of use cases, and then start actually implementing, walking through how to take, certain mathematical formulas and then implement them in a NumPy fashion, and kind of NumPyify NumPyify Python code in order to run more efficiently using this particular library. So, and then after that, maybe we'll kind of dive into some of those libraries that are kind of written on top, kind of pandas, the SciPy, scikit-learn, things like that, things of that nature. So kind of give you a basic ground level understanding of what's going on in NumPy. And that way, when we kind of work our way into those libraries built on top of it, you have a kind of a fundamental understanding of what's going on underneath the hood. So I hope you enjoyed, and I'll see you in the next one. Thanks.